Today our topic is 20.3, that is independent events, right? In previous class we have studied 20.2, that is mutually exclusive events. Okay, if two events are independent, then one does not interfere with the other. This is basically the definition of independent events. For example, suppose you are tossing a coin and drawing a card from a pack. Thus, result of the coin, head or the tail, does not affect the uh, does not affect which card is selected. So the both are independent. You can solve simple problems or independent events by drawing a table of equally likely outcomes. You can say that here is the example. Janine has two fair spinners. One of them has the numbers 1, 2, 3. The other has the numbers 3, 4, 5, 6. Janine spins both spinners and adds the score together. So we have to find the sample space. How we can find the sample space? For example, one spinner has first spinner has 1, second spinner has 3. So your answer of adding the scores is 4. The next will be adding the score 5. The next will be adding the score 6. The next will be adding the score 7. Again, second with 1, second with 2, second with 3, second with 4. So this is basically called the sample space, right? So work out the probability that Janine has total is 7, right? So first of all, we have to draw the table of total scores. So this is the table which we have uh, just drawn. That we have to add all the values of the spinner A and spinner 1 and spinner 2, right? And you can say that in part B, work out the probability that Janine has total 7. So total 7 in this place, in this place, and in this place. You can see that there are just 3 ways of finding the total 7. It means that the total favorable outcomes are 3 and the total outcomes are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, 11, 12. So the probability of total 7 is 3 over 12. So 3 over 12 can be written as 1 over 4 in simplified form. So this is the basically solution of this example, right? If the event A and B are independent, then we have the formula that probability of A and B is equals to probability of A cross probability of B. In previous case, we have studied the mutually exclusive events. In mutually exclusive events, we have to find the probability of A or B, that is equals to probability of A plus probability of B. But in independent events, we have the probability of A and B, that is equals to probability of A multiplied by probability of B, right? This is very useful method for working out the probability of the combined events as in the next example. So you can see that when Laston drives home from work, he has to pass through two sets of the traffic signals. The probability that the first set will be on red is 0.4. First set is red, that has the probability 0.4. The probability that the second set will be red, that is 0.3. Calculate the probability that both sets will be on red. Calculate the probability that neither set will be on red. So first of all, we have to find the probability of both red, that is probability of first red and probability of second red. So what is the probability of first red? That is 0.4. Multiply by using the previous formula. We have the probability of first red and probability of first red and second red, that is equals to probability of first red multiplied by probability of second red. So what is the probability of first red? That is 0.4. What is the probability of second red? That is 0.3. When we multiply these two probabilities, your answer will be 0.12. So this is basically the probability of both red. Now we solve the part B, in which we have to calculate the probability of neither the set will be red. So the probability of first not red and second not red, we have to find this probability. Again we use the formula that probability of first not read multiply by probability of second not read. So what is the probability of first not read? We have the probability of first read, that is 0.4. So first not read will be 1 minus 0.4, right? Again, probability of second not read, second read is 0.3 and second not read will be 1 minus 0.3. So this will becomes 1 minus 0.3. When we simplify it, first term will become 0.6, second term will become 0.7. When we multiply these two numbers, your answer will be 0.42. So this is your solution for independent events. So in this signals case, we have also two independent events. Here we have the next exercise, that is 20.3, and you can see that in this exercise we have total 8 questions. You have to calculate the questions of 20.3 exercise, which are the factors of 8. So which are factors of 8? That just the numbers in which the 8 becomes. For example, 1 stable 8 becomes, that's why 8 factor is 1, right? So 1 is the factor of 8, 2 is the factor of 8, 4 is the factor of 8, and also 8 is the factor of 8. So all these are the factors of 8 by which 8 can be divided completely. So this is called the factor. So now you have to do this exercise quickly. In the next class we have to do the topic 20.4, right? You have to do these questions and send it to me on WhatsApp, and that's enough for today. In the next class we will start, right? Okay, Allah Hafiz.